Welcome Pure Maths 3 students to week 3 of our maintenance program. We're continuing to work on quadratics and functions, which we've already studied, and so this is just keeping it fresh as we move on to new topics. Okay, well, let's see how we go with this. The first question we have today is find the number of roots in this equation here, x squared minus 3x plus 4 equals 0. So we're going to use the formula b squared minus 4ac, which is the discriminant. Excuse the writing. I don't even know if I spelled that wrong. All right. Okay, now all we need to do is plug in the value. So we've got minus 3. We're going to square that because that's the b value. The a value is 1. Right, because that's the coefficient of the x squared. And then the c value is 4. What does this give us? 9 minus 16 equals negative 7. Okay, now if we get a negative value, that means no roots, because the square root of a negative answer doesn't give us a real value, it's undefined. Sorry, not undefined, it'll give us a imaginary number, which we'll talk about in Pure Maths 3. Okay, so it's no roots. Okay, next one, we are looking at the simultaneous equation. We're trying to solve it and find the values for x and y. So we're going to put x squared minus 6x plus 5 on one side, so that's equal to y, and you also see that this is equal to y, so I'm going to make those two equal. Now what I will do at this point is I will bring everything across to the left hand side, so I'll get negative 7x and then plus 6 equals to 0. And I think if I factorize that, I could factorize it like this, and therefore I get x is equal to 6 or 1, and then at this point therefore y equals, now I can plug those values into this bit here. So we're going to get 6 minus 1, which is 5, or 1 minus 1 is 0. So our two values, our coordinate pairs are 1, 0, or 6, 5. And those are the two pairs that we have. Now, nextly, what have we got here? We've got to solve this inequality. So, again, I'm going to factorize that. Yep. So I can factorize it like this. Now, if I just do a quick sketch of this, I know that I've got a root at 4, and I've got a root at 1. So 1, 4, and my quadratic's looking, oh dear, I'll just adjust that slightly. Okay, so that's what my quadratic looks like, and I want less than 0. So I'm looking at between those two values, that's where it's less than 0. So what I would write there is 1 is less than p is less than 4. And that gives me the range of values where I'm going to have less than 0 for that function. Okay, so the next one I've got to write the answer in surd form. There are a couple of ways of doing this. Potentially we could... It's greater than or equals to 0. We could use the quadratic formula. I think we will use quadratic formula. So I'm going to use minus 6 plus or minus the square root of minus 6 all squared. Minus 4 times 1 times 7. All over 2 times 1. Give ourselves a bit more space. Okay, now we simplify that. We're going to get 6 over 2 plus or minus the square root of, now that's 36 minus 28, which is, was that 8, isn't it? So it's going to be square root 8 over 2, and that's Right, those are the x values are greater than or equal to 0. Okay, so we get 3 plus now square root 4, square root 2 over 2, greater than or equal to 0. And we can simplify that by going 3. Now the square root of 4 is 2, so the denominator 2 cancels it out with that, so plus square root 2. Oh, and I should have my minus here. Or minus square root 2. And those are the roots. Now, okay, maybe I should have just found the roots first. I'll just turn those into equals. Now, what this means, what does this mean? Okay, if we're to sketch this graph, we've got a root at 3 plus square root 2. So that's like over here somewhere. 3 plus square root 2. And then we've got one at 3 minus square root 2, which is over there somewhere. And we're wanting where it is greater than or equal to that. So we're wanting greater than or equal to 0. So we're wanting the root that to the left and this root and to the right. So there's two ways of writing this. Okay, so we can say if we want this bit here, we would say that x is less than or equal to 3 minus square root 2. And if we want this bit here, we'd say or x is greater than or equal to 3 plus square root 2. Okay, so hopefully that makes sense. Moving on to the functions questions now. Now, let me see. Okay, so we've got fx, we've been given it's x over x plus 3. We are given a domain, so we're allowed x as a member of a set of real numbers, but it's not allowed to be 3. And we know that we've got to find the value when the function is equal to minus 5. So we're just going to go x over x plus 3 equals 5. And then the next step is to multiply across the x plus 3. So we're going to get, I'll just do that in one step, right? It will be, oh, sorry, it's meant to be minus 5. Read the question, minus 5. So we get minus 5 into x plus 3. So we get x is equal to negative 5x minus 15. I'll pull the 5x across by adding 5x to both sides, and I get this. And so I should get x is equal to negative 15 over 6. And that would be my answer there. Okay. Well, this next one, what have we got? A function f is such that fx is equal to this here for x is less than or equal to 1 over 2a, where a and b are constants. For the case where f minus 2, so we put a minus 2 into it, is equal to this, and f minus 3 is equal to this, find the possible values of a and b. Okay, this is a little bit more complicated, so we're going to do it in parts. We're going to do this bit here first. Make that a bit smaller so I can write with it. Okay, so with that bit, what I'm going to do is I'm going to put minus 2 into my x values here first. Okay, so I'm going to get a squared, and then minus 2 for x values. Minus 2 times minus 2 is positive 4. So it'll be 4a. And then I'm going to put it in here. So it's minus a times minus 2. Now, minus a times minus 2 is going to be positive 2a. So get rid of that. Positive 2a. Come back. Okay, and then we've got that plus 3b. Now, that is what I get when I put minus 2 in, and they say that it's also equal to this bit here. So these two things are equal. Now let's look at that. Well, I can take everything across to, well, I'll take the a's across to the left-hand side and the b's across the right-hand side. So I subtract 4a squared from the right-hand side, and that gets rid of that. I'm left with 2a. And then I'm going to move the 3b across the other side by subtracting it, so I get minus 4b plus 8. And so a is equal to negative 2b plus 4. or conversely, we could do it another way as well, couldn't we? Yeah. Have I done that correctly? I think I've done that correctly. Okay, now we're going to do this bit here. They say that's what it equals. Now, instead of putting a 2 in this time, we're going to put a 3 in. Okay, so let's put a 3 into this and see what we get. So I get 3 squared is 9, so I get 9a squared minus 3 times minus a, so that's positive 3a, plus 3b. And then we're told that it's equal to, equal to 7a squared minus b plus 14. Bring it all, so I'm going to bring the a's across here, so I get 2a squared plus 3a, and then I'll bring the b's across here. 4b equals 14. Okay, so I've got something roughly like that to start off with, right? Okay. Now, let us see. What I'm going to do now is I'm going to use this value here, which I've been given, and I'm going to insert that into my a values. Okay, so let's try that. Let me see. Hang on. I hope I haven't made some errors. It's looking a bit different from when I did it the other day. All right, we'll just see what happens. What could possibly go wrong? What could possibly go wrong? Okay, so what we're going to do is we're going to go 2 into negative 2b plus 4, and that's going to be squared, plus 3a plus 4b equals 14. I'm just wondering if there's an easier way of doing this. Maybe, I'm just having a bit of trouble with this thing. I can't delete stuff. Maybe if I try this. But why? Oh yeah. Okay, that's good. Oh, that's good. Okay. Maybe what would be easier, instead of having the squares here, maybe if I work with this stuff here and change it so that b is the subject of the formula, I might be better off. Okay, so we could maybe go 2b equals 4 minus a, and so b is equal to 2 minus half a. And we can potentially now put this, yeah, that's better, and we can put that into here. So well, that's what I'm going to do right now. So let's just drag this over here. That's what I'm doing there. Okay, now let's do that. So we've got our 2a squared plus 3a plus 4 into b, which we found to be 2 minus half a, is equal to 14. And so I'm going to get 2a squared plus 3a plus 4 times 2 is 8. And 4 times minus 1/2 is minus 2a equals to 14. Let's gather all of our terms. Now we've got plus a. We'll bring that 14 across. That gives us 8 minus 14 is negative 6. Should be equal to 0. And now, is that correct? I think it is. Okay. And now we're going to factorize that. So we go 2a, a go plus 2 minus 3. And so I think I'm going to get a is equal to 3 over 2 or minus 2. And alright, so that leaves us with this last part of the question. For the case where a is equal to 1 and b is equal to negative 1, find the expression for the inverse and give the domain of the inverse. Okay, so what we're going to do here is we're going to write what fx would be. Now, if a was equal to 1, then, so I'm just looking at this bit here, a squared would be 1, right? So we'd get x squared. 1 times x squared is x squared. Then minus ax, which is minus 1. And then 3b, so that's 3 times negative 1 minus 3. Oh, sorry, that should be minus 1x, okay? My handwriting's getting a bit dodgy here. Minus x, because the a was in front of the x, okay? So minus x. And then minus 3. And then our domain is for x is less than or equal to minus 1 over 2a, which is 1 over, in this case, 1 over 2, because a is 1. Okay. Now, if we are going to find an inverse of this, the first step is you want to complete the square. Okay, this is the easiest way for us to find an inverse of a quadratic. Okay, complete the square. Right, I think that's what I want. So that should be 1 over a quarter. That's looking a bit dodgy. And then I've got my minus 3. That's my domain there, so I'll just ignore that. Okay, so I halved the coefficient of the x, which is 1, so that's minus 1. And then minus 1 squared would be minus 1 quarter. So I want to subtract that off at the end. So essentially what I've done is this bit here is equal to that bit there. Okay, now let's move on. Okay, now what we'll do is we will simplify that. So x minus 1/2 all squared. Now minus a quarter minus, so it's minus 3/4, and another way of saying that would be negative 13/4, wouldn't it? Okay, so that is the function. Now if we're going to that's a 4 down there. If we're going to find the inverse, we're going to swap over the x and y values. Okay, so I'll do that in red here. X is equal to y minus 1/2 squared minus 13 over 4. And we can get that 13 over 4 to the other side. So minus 1/2 all squared is equal to x plus 13 over 4. And then to get the y out of here, we're going to square root the both sides here. So we get is equal to the square root of x plus 13/4. And plus or minus. Now, okay, and then we will bring the 1/2 across, so we get is equal to this, plus or minus the square root of x plus 13/4. And we've got to think about the domain. Now, remember, the domain of the inverse is equal to the range of the function. So here's our function. What is its range? Well, handily, we've put it into completed square version. So the range of the function would be fx is greater than or equal to minus 13/4. Okay? So that would be the minimum point. And therefore, that means the domain of the inverse, I'm going to write it in function notation. So this is the function. Inverse function is equal to 1/2 plus or minus the square root of x plus 13/4. And therefore the domain And remember, domain is input, so we're going to put x is greater than or equal to negative 13 quarters. Negative 13 quarters. And there we are. That is done. All right, I hope that makes sense, guys. Keep working hard. Make sure you are practicing a little bit of maths, a couple of hours or so a week outside of your classes, because you're going to need that if you're going to pass this course. Just talk to the seniors who did the course last year. It's necessary. Okay, make sure you're asking me questions in the comments or on ThinkWave. Happy to help. All right, take care.